Okay, let's look at some more examples of adaptation by farmers, groundwater issues, rainwater harvesting, technology adaptations, adoptions, and so on. Climate adaptation by farmers in 3 communities in the Maldives. Just looking at key messages. Farmers need a valid source of information at the island level on climate change and its impacts in order to adapt to the changing conditions and to be more resilient in the future. Island states are specific cases of how sea level rise, salinization, water issues, freshwater issues affect them. Women farmers who tend to the home gardens and the homestead plots with assistance from their families, and those who have participated in agricultural workshops conducted in the island are more likely to contribute to the social capital of farming. So if you think of farming as adding to GDP, social capital, and so on, the people who are trained and are willing to learn contribute more to the capital of farming, social capital. Farmer cooperatives are an important institution for farmers to build trust and reciprocity, which has been identified as one of the weakest links among the surveyed communities. So this idea of building trust and who is the messenger depends on the credibility, saliency, and legitimacy of the message and the messenger. So if you go into any place and start telling them that things are changing, if they identify with what you are saying at the local level and it makes sense to them, they may ask you what the solutions are, and then the cooperatives are good distribution centers for knowledge. So there is usually a trusted agent like an extension worker or so that can translate the climate change message to them, and then farmers cooperative can be important institutions where farmers have trust and reciprocity. Then the ideas can spread much faster. That's just usually how it works. Moving to climate sensitivity of groundwater systems in South India. Does it matter for agricultural income? Okay, key messages here. Flat or fully subsidized electricity pricing policy in Tamil Nadu, a southeastern state on the Bay of Bengal, negatively impacted the groundwater table, implying that subsidized pricing has lowered the water table. Obviously, when you have electricity paid for or subsidized and there are no limits on pumping groundwater for irrigation, farmer will go on irrigating, and there is plenty of evidence from all across India and elsewhere that even when there is good rain, farmers just irrigate to be safe. So how to incentivize them to use less water comes down to again using things like early warnings, where if you give them reliable information that it may rain tomorrow or day after, and they can look at the crop stress and decide not to irrigate if they trust your forecasts. Okay, increase in temperature had a negative impact on farm income, while increase in rainfall had a positive impact on net revenue. Increase in depth to water reduces farm income. So if you have to drill from deeper, then farmer income goes down. An important policy implication of the analysis is the negative impact of well density beyond a threshold level on farm income. Okay, an important policy implication of the analysis is the negative impact of well density beyond a threshold level on farm income. So how many wells there are and how the farm income depends on it has a kind of a threshold that has some deeper meaning that you can go and read to see how policies can be set to control groundwater irrigation water use. Many states in India have incentivized it the other way. So you have subsidized electricity, but if you use less than your quota, let's say, you get paid for savings you made. So that allows them to think about using electricity more carefully, because they can actually use it to cash in the energy that they didn't use. Okay, it's use or lose subsidy, then they will just use as much as possible, whereas if it's save and earn money, then they will go the other way. Technology adoption, part 3 of the book, looks at rainwater harvesting and rural livelihoods in Nepal here. Key messages: rainwater harvesting helps mountain farmers to overcome water scarcity during dry season and in diversification from traditional cereal crops to high value vegetable farming. You know, Nepal is in the Himalayan foothills with lots of topography, landslides, heavy rain, earthquakes. It's a poor country with all kinds of compound events, disasters. So earthquake comes, floods come, food security is affected, and so on and so forth. The investment on technology could be recovered in 2 years' time, but adoption of technology is low due to the high startup cost in the absence of subsidies. So unless the government or banks, development banks or private donors fund the initial adoption of technology, the adoption tends to be low because of the initial cost of adopting it. Providing training and subsidy to the farmers would help increasing the adoption rates of technology as a part of climate change adaptation. Seems obvious, and yet you have to go and learn what the region specific issues are, what the region specific mental models are, and so on, what the region specific climate issues are as well. Local strategies to build climate resilient communities in Bangladesh. Key messages here: creating alternative market chains for fuel like liquid petroleum gas reduces forest dependency for food, for fuel wood, and is supportive towards forest conservation. So LPG is considered a low emission fossil fuel, but obviously it's still fossil fuel, but it can help reduce biomass burning and help forest conservation. There is now new literature arguing that the gas stoves in the house are deadly for health, but this is still out for debate, I think. Bandaling, which is the way the things are done, is an indigenous bamboo structure, still has the merit to reduce river erosion in small river basins and to reclaim agricultural land. So that's a local strategy to build climate resilient communities. Floating agriculture, for example, Baira, enables communities to become resilient against waterlogging in the soil from excess irrigation or heavy rainfall, and also offers income generating opportunities. It's kind of like a hydroponics. Okay, so LPG supply chain in Ukhia Upazila. Upazila is a sub district, I suspect, Cox's Bazar. So you can see it's a kind of a detailed chart. So LPG distributor is here, so he's transporting it to LPG store in the bazaar, and then company is distributing it to another company, to houses and restaurants, and here there is another supply chain to UNHCR, IOM providing LPG to camps. So there are non-governmental organizations that are freely giving it to, let's say, the refugees, which are the Rohingya community. Rohingya also sell LPG in local markets or to local villagers. For direct sell, they prefer local restaurants, as restaurants consume LPG quickly and return their cylinder in time for free refill. So you know what's happening here. So there is a plan to help the Rohingyas, but Rohingyas are using the gas to sell it and make money. So they may be burning biofuel to sell the LPG they are getting for free. So unintended consequences, but this is something that's avoidable. So all these also feed into host communities like houses and restaurants. So host community purchases LPG from local retailers. As Rohingya sells LPG in cheaper price, they often buy LPG from Rohingya. Rohingya are getting it free, so they are selling it cheaper than the market price. So you can see what a strange situation you can create from incentives. Further, among the refugee households, there has been an 80% drop in the demand for fuel wood, and among the local households it fell by 53%. Biomass burning goes down. It's important to note that local households were not given free LPG refills after their first 6 months of the program, but once they got used to LPG, they stuck to it even though it was not free anymore. Total demand for fuel wood fell from 462,000 tons to 38,000 tons, so order of magnitude drop, much below the pre-refugee demand for fuel wood in the area, which was 95,000 tons per year. The chain of events that led to such a fall in demand for fuel wood is more interesting as a lesson learned. Okay, so here are the floating beds, kind of like hydroponics. Okay, so moving to chapter 13, what influences rural poor in India to refill their LPG? We are in technology adoption still. Rural income generation schemes, female literacy positively influence LPG refills. While male workforce participation increases LPG refills, female workforce does not. So that has to be figured out. Vicinity to forest has heterogeneous effects depending on the type of forest. So if you are close to the forest and you can get free biofuel, depending on the type of forest, it may affect your reliance on LPG as a technology adoption. Okay. This is kind of related to adaptation, but not directly in terms of reducing emissions, but just dealing with impacts. Okay, so in this case, conclusion and policy implications are worth reading. Today, about 3/5 of India's households rely on fuel wood and other solid fuels. Continuing these consumption patterns could lead to significant environmental impacts, especially considering India's high population growth and increasing fuel wood extraction. India will need to move away from fossil fuels gradually to meet sustainable development targets and carbon mitigation targets. Increasing household LPG use is one of the several pathways to achieve this. Eventually, you want to get out of LPG as well, since that is a fossil fuel. However, projections of the International Energy Outlook report suggest that in 2030, 580 million people in India will still be using traditional fuels and would then fall short of its targets under SDG 7, which is on affordable and clean energy. Projections are always uncertain, especially if population demographic assumptions involved are not very well known, so we have to wait and see. This is despite government efforts to improve access to subsidized connections through various schemes. The main reasons cited for this gap in meeting targets are poor implementation, supply shortage, and lower affordability. While two of these issues need to be addressed from the supply side, this chapter focused on the push needed from the demand side to improve LPG uptake. Okay. Further, our analysis indicates that poorer households are more likely to switch fuels if their disposable income increases through the employment generation schemes. The expendable MGNREGA, it is Mahatma Gandhi National Rural Employment Scheme, which is a policy determined variable, and the decision makers could ensure a win-win situation of triggering the triple benefits of reduced household air pollution, reduction in forest dependence, and reduced emission of carbon, in turn promoting affordable and clean energy under helping progress on SDG 7 for rural households. Switching to cleaner cooking fuels such as LPG has the potential to deliver extensive health, social and environmental benefits, including positively affecting climate in the short term. It can further support achieving a few of the targets under SDGs. Since India is committed to achieving the Sustainable Development Goals by balancing economic, social and environmental goals, the wide use of LPG should be a small but sure step towards achieving these objectives. Okay, I will leave this here and come back and move to small-scale solar solutions for energy resilience in Bangladesh. This is already 14 minutes, so that's good enough for now. Let's come back and talk about rooftop solar and so on. Okay.